do this reaction so that a primary alcohol will form. So this is the reaction. Now in this case, you need to identify that if I'm using carbonyl, so what type of carbonyl I needs to take to generate a primary alcohol. Primary alcohol means 1 degree alcohol, na?
Yeah, yeah, yeah.
What sort of
I was
reagent
just
I'm using?
thinking,
Mm-hmm. Yeah.
I kind of misunderstood. I was thinking of like this part. I was already thinking like of this part. I wasn't looking at like the first, like the reactants. Um,
Yes, so you
yeah.
need to identify firstly the like this. Let's suppose primary.
Mm-hmm.
So primary alcohol is this is the primary alcohol. If I attach
Mm-hmm.
R, R is any alkyl group. Okay, CH2OH.
Mm-hmm.
Okay, so I need to prepare this compound. So for this, I need formaldehyde. This is known as formaldehyde.
Wait, so I'm right?
Formaldehyde or methaldehyde.
Was I
Methanal.
right then?
Yes.
Oh, okay.
Okay.
I had an idea it would be like all hydrogen because the other ones were like CH3.
Mm-hmm. Mm-hmm.
Yeah.
Yes, so methanol and what sort of reagents now I need to use here to produce primary alcohol?
We were using RMGX, right?
RMGX, great. Then,
RMGX, and then so like the R I think attaches to the carbon, right? And then the oxygen is like the bond is like broken.
hmm
So then oxygen, so then what happens is that you oxygen it's but is just bonded with like a there's only one bond
hmm
between carbon and oxygen and the rest are lone pairs, right?
yes. So, firstly, in alcohol, we proceed with
Mm-hmm.
classification. Classification in
Mm-hmm.
allylic and vinylic. What is allylic and vinylic part?
Allylic is when you have an alcohol group that's attached to an sp3 carbon, which is then attached to an sp2 carbon.
Great. And what is vinylic?
Vinylic is when the carbon is attached to an sp2 carbon directly.
Yeah, good. Good. Then, then we discuss IUPAC.
Mm-hmm.
After IUPAC, we saw a structure of alcohol. Alcohol is basically sp3 hybridized, okay, like O in alcohol, but oxygen is
Mm-hmm.
having two lone pair. So, what the two lone pair affect the structure of alcohol? How, like the two lone pair affect
It'll
the?
reduce the bond angle by like I think 1 degree.
Yeah, great.
It'll make it narrower, so there's
Yes.
more steric hindrance, right?
Just because of a lone pair repulsion.
Mm-hmm.
Okay, then we proceed to method of preparation. In method of preparation, we saw by two methods, like from alkene and from carbonyl, we can form alcohol. Okay, so from alkene, there is three methods. Can you tell me all the three methods?
Um, I need to do a little bit more revision on that end, but what's it called? There's hydration, oxidation, there's oxymer
Oximer, not oxidation.
wait, hydration
Hmm.
is it's oh yeah, it's not I'm sorry.
Hydration.
Uh just hydration, yeah. And then oxymercuration, demercuration, and then hydroboration oxidation. I got the first and
Yes.
the last one mixed up. Yeah.
Yes. So
The last one has oxidation, right?
yes. So let's
Okay.
suppose I generate a product which is with anti-Markovnikov rule. Okay. So in
Mhm.
that case, which type of reaction that will be from alkene?
Anti-Markovnikov, it's going to be on the nucleophile will attach to the less substituted side of the double bond.
Yes. And what is the name of the reaction?
Um, anti anti-Markovnikov?
Yeah. And in hydration, oxymercuration, demercuration, hydroboration, oxidation, which sort of reaction give anti-Markovnikov addition?
Anti-Markovnikov is going to be the hydroboration.
Great. And if there is ring expansion will proceed, so in that case, which type of reaction that will be?
You can have a four-membered ring, right?
Ethanol?
Wait,
I'm
for hydroboration oxidation?
no. I'm asking a general question. If let's suppose
Okay.
in any reactant there is a ring
Mm-hmm.
expansion or alkyl shift will proceed. So, what type of reaction that will be?
Carbocation?
Yeah, and carbocation in which part of like from alkene to alcohol?
From alkene to alcohol.
Uh,
Um, like any sort of like a ring, any sort of ring expansion.
I'm asking you. There's three reactions now from alkene
Yeah.
to alcohol. So, among which reaction that will be lie if I have a ring expansion part in a reaction? So, is that
Hydroboration oxidation.
hydroboration oxidation if I proceed with ring expansion part? Are you sure?
Yeah.
In ring expansion, that is a generation of carbocation will take place. Yes or no?
Yeah.
So carbocation is formed in hydration now, not hydroboration oxidation. Do you remember? Carbocation form and carbocation rearrangement lie in hydration part. Only in hydration part.
Oh, right. And that's where the alkyl and hydride shift comes, right? Okay, yeah, not
Hmm.
oxymercuration, demercuration,
Yeah.
or
And
hydroboration.
let's suppose I have a reactant alkene, like unsymmetrical alkene, and I react that unsymmetrical alkene with BS3, THF, H2O2 in basic medium. So, what sort of reaction that like this line? What sort of reaction?
BHT, THF,
H2O2, that is peroxide in basic medium.
H2O2, that would be hydroboration, right?
Yeah. And if I'm using HgOAc twice, uh, and the THF and H2O and NaBH4. So in that case,
Oxymercuration, demercuration.
yeah. So NaBH4 is a type of reagent. What NaBH4 will do in that reaction? What is the use of NaBH4?
Sodium borohydride, right?
Yeah. So what sodium borohydrate will do in that reaction?
Um,
Sodium borohydride is what sort of reagent? Is it reducing, oxidizing, or anything else?
I think it's oxidizing, right?
No, it's reducing agent.
Oh, so wait, sodium
NaBH,
borohydride. Oh, yeah, it's reducing. Sorry. Yeah, it's reducing.
yeah. So okay. So after that, from alkene there is three reaction. Then we discuss from carbonyl. So in case of from carbonyl, we go with two reaction. First with Grignard reagent. What is Grignard reagent?
It oxidizes?
No.
I think I
Like
need to
what is
revise that.
chemical composition of Grignard reagent? How it generate?
Alkyl group, magnesium, and then it's an magnesium alkyl halide, right? Al
Yeah. So in that
Magnesium
case,
alkyl.
how the bond will break
How will the bond break?
between alkyl magnesium
It's
halide?
isn't the R group alkyl group gonna interact with the carbon?
Yeah.
So
Interact
then
with the
that's how it
carbon, it interact with carbonyl. Why carbonyl?
with the carbonyl, yeah.
Why?
Carbonyl because of the electron distribution.
Yeah. Carbon is partially positive or negatively
If
charged.
carbon is positive, oxygen is negative, so there's a partial charge.
Yeah. And
Yeah.
in RMGX, which is R is in like partial positive or negative.
R is negative.
Yeah, so that is why R negative attack to the carbonyl group in which the carbon is partially positive charge or a little bit electronically deficient part. Okay. Then after Grignard reagent, we discuss generation of alcohol with reducing agent. So there is three reducing agent we discuss. First, you tell me what is reducing agents.
Reducing agents, there is sodium borohydride, right? And then lithium aluminum hydride.
Yeah. What is reducing agent? What they will do?
Oh, in general,
Yeah.
um, reducing agents make the molecule more substituted, or they add something. Because I remember oxidation reduction, like oxidation adds a plus and then reduction adds a minus, or is it the opposite? Reduction adds a plus and oxidation adds a minus.
Reducing agents are used to donate hydrogen, H minus.
Okay, so it adds negative. No.
No, there is not negative and positive. The first thing you need to know what is reduction and what is oxidation. Do you know about them?
That's what I was like asking you because I learned that in general chemistry. I don't know, it's been a long time.
Okay, so let's
So
suppose.
maybe you could just
Mhm.
briefly like
Okay,
explain, possibly.
so reduction and oxidation. Okay, so there is three methods on those bases we can differentiate reduction and oxidation. So let's suppose first thing that is hydrogen.
Mm-hmm.
There is oxygen on the basis of oxygen and on the basis of electron. Okay, so on the basis of these three type, we differentiate reduction and oxidation.
Yeah.
So if there is addition of hydrogen will take place, then it will be reduction. Okay,
Mm-hmm.
and if removal of hydrogen take place in any reaction, then it will be oxidation. Okay, after that addition, oh sorry, removal of oxygen take place, that means it is reduction, and removal of sorry, addition of oxygen will take place in any reaction, that means oxidation.
Okay.
Okay, then electron. So in case of electron you will remember a term, oil. Okay, oil means oxidation is losing. Okay, oxidation.
Oh, oil rig. I remember rig. Reduction is gain. Yeah, I remember that.
Okay, so this is reduction and oxidation. Now I'm giving you some example, then you tell me that which reaction is oxidation and where is H2 plus I2 gives to HI, Fe plus converting into Fe3 plus, then H2 plus O2 give H2O2, and Fe plus O2 gives Fe2O3. Okay, so these are the three reactions, Cl converting into Cl minus. Let's suppose these are the reaction. Okay, so let's start with the first reaction. In the first reaction, you need to identify that the given reaction is a reduction reaction or oxidation reaction.
Um, the first one, since there's an addition of hydrogen, that should be reduction. Or actually, no. It's the same. Two hydrogen. Remove hold on. You're taking away one iodine, right?
Yeah.
So that would be if you're removing that, then it would be reduction.
Removing what?
Or like you're removing an iodine which has a negative charge, right?
See, in this whole, firstly we check hydrogen. Is there any hydrogen transition will take place in this reaction? So yes, there is hydrogen will add to iodine. Yes or no?
Mm-hmm.
So this reaction is known as, if in any reaction hydrogen will add. So in this, that reaction is reduction reaction. Okay, so this is reduction reaction. Okay,
Mm-hmm.
then we will check this one. Fe plus converting into Fe3 plus. So can we check with hydrogen? Is there any hydrogen in this reaction? Hmm?
Is there any hydrogen? No.
Is there any oxygen?
No.
Okay, so hydrogen and oxygen is not here. Then we'll check with electron. So Fe plus converting into Fe3 plus. So that means how many electron changes here?
2.
Plus one converting into plus three are two. So two electron will this Fe plus and donates two electron or gain two electron.
Yeah,
Like
gain?
losing of electron take place or removal.
I think, wait, is it because it's going from 1 to 3 plus.
Mhm.
Oh, losing.
Losing, absolutely.
Okay, so if you're losing charge, then that means it's reduced, right?
It's losing charge means oxidation
But
is losing.
oh, okay. So this is
And
oxidation.
yeah, so this is oxidation. Great. Then in case of H2 plus O2. Okay. Now in this case, is there any hydrogen?
In this case, yes.
Is there any oxygen?
Yes.
So in this case, hydrogen will converting H2 to H2O2. Okay.
Hmm.
So what will be the process? Reduction or oxidation in terms of hydrogen?
In terms of hydrogen, I mean,
Hmm.
it's the same number.
No, like H2 is hydrogen is here. But after the reaction, hydrogen add oxygen now.
I see. Okay, yeah. So then, because if you're adding oxygen, that means it's an oxidation. If you're adding hydrogen, that means it's reduction. So then,
So
so if you're adding the
in case of hydrogen, there is H2 and H2. So do we add hydrogen here?
no, I think we're adding oxygen,
Oxygen.
right, to the
Yeah, yeah,
hydrogen, yeah.
yes. So if addition of oxygen take place, then it's oxidation.
Mm-hmm.
Oxidation. And if okay, so from H2 to H2O2, that is oxidation. Let's suppose if I'm having O2, so O2 is converting into H2 and O2. So in that case, what sort of element or things added in O2?
Mm, is it peroxide?
How? Like, I'm just asking you from O2 to H2O2. That is reduction or oxidation?
Mm, reduction,
Yeah. How?
because you're adding hydrogen.
Yeah. So that is reduction. So let's suppose if in any reaction, reduction. If any in any reaction, oxidation and reduction both take place simultaneously. So in that case, that reaction is known as redox. Do you know redox
I've
reaction?
heard of it, yeah.
Okay. Now we'll check next reaction, that is Fe plus O2 gives Fe2O3.
Mm-hmm.
So tell me.
Okay, so you're adding an oxygen to iron, right? Are you also adding? Hmm. You're adding an iron, but then
Hmm?
you're also adding an oxygen.
We are only adding oxygen now in the whole reaction. Is there any hydrogen? Is there
No,
any?
no, no. I said there's another iron, is what I was saying, not
Yeah.
hydrogen.
Yes, yes, yes. So in terms of iron, what will be the process?
I mean, you're adding an iron, right? So iron is +3,
Adding,
right? Or +2 rating. Huh?
we are adding oxygen to the iron.
But how do I know what's being added? I guess the second like reactant.
No, we only check hydrogen and oxygen.
No, no,
Okay.
no, that's not what I'm asking. What I'm asking is like, how do we know if we're adding like oxygen to iron or iron to oxygen? Like, how does the order work? I
The
don't know.
first,
Maybe, huh?
first, the first thing which we are using is reactant, and then when like let's suppose I'm writing here O2, so O2 will add it in iron. Okay. In the case hydrogen, and so oxygen is added into the hydrogen. That's how I2 is added into hydrogen like that.
Okay.
Yeah. So in this case, Fe is added into, oh sorry, O2 is added into Fe. So what will be the process? Is that reduction or oxidation? Hmm.
Oxidation.
Yeah, oxidation. And this is the last, Cl converting into Cl minus. So in that case,
Hmm. You're adding charge, right? Or adding electrons. So that means reduction.
great. Then there is two terms come, that is reducing agent and oxidizing agent. Okay.
Mm-hmm.
So what reducing agent and oxidizing agent will do? Oxidizing agent and reducing agent, they are basically agents. So what they will do, reducing agent reduce any other compound, okay, and oxidized itself. Okay, and oxidizing agent reduce itself, okay,
Mm-hmm.
reduce itself. Okay, so let's suppose I have a reaction, that is redox reaction. In this case, see, oxidation and reduction both reaction will take place. Okay, so if I'm asking you that H2, okay, H2 converting into H2O2, so this reaction is oxidation. Okay. Hmm.
Mm-hmm.
So in this case, O2 used in the oxidation process for hydrogen. Hmm?
Mm-hmm.
You can, okay, so let's, you can say that if there is any oxidation will take place of any reagent, so that reagent is known as reducing agent. And if any reagent with which proceed with reduction, so that agent is known as oxidizing agent. Okay, these two terms you needs to learn. Okay, so let's suppose I have a reaction H2 plus O2. That reaction will proceed. H2 plus O2 gives H2O2. Now in this case, from H2 to H2O2, oxidation will take place.
Mm-hmm.
Okay. So can I say that H2 is also working as a reducing agent?
Mm-hmm.
Okay. Reducing agent. And if from O2 to H2O2 go, then here is reduction will take place. Yes or no?
Mm-hmm.
So can I say that this is a oxidizing agent? Oxidizing agent. That O2 is working as oxidizing agent also. Okay.
Mm-hmm.
Any doubt up to now?
Give me
in
1 second.
oxidation reduction.
Yeah, let me just copy it down and then I'll like tell you
Okay.
if there's anything. Hold on. Mm, no, I'm good.
Good. Okay.
Mm-hmm.
Okay. So now NaBH4. NaBH4, NaBH4 donate its hydrogen and it will converting into NaBH3 plus H minus. Okay. So
Mm-hmm.
in this case, from NaBH4 to NaBH3, okay,
Mm-hmm.
reduction take place or oxidation take place.
It's gonna be oxidation.
It's oxidation. So can I say that NaBH4 is also working as reducing agent?
Mm-hmm.
Yeah. So that's how the NaBH4, LiAlH4 both are working as reducing agent. Okay.
Mm-hmm.
Any doubt up to now?
Mm, no, but I think what's it called? I wanted to say I think I need to, based on like all the questions that you asked me, I think I really need to go back to the mechanisms, and also I don't really remember all of the reagents for each reaction. I remember some, but maybe not all completely.
Okay, let's solve.
So,
Okay. No issue. We'll solve here these questions. Hydration of propene in the presence of dilute sulfuric acid. So first you tell
mm-hmm,
me, uh, we need propene firstly. So what
mm-hmm.
is propene?
Propene is a three-membered carbon.
Membered.
No, not membered, sorry, a three carbon chain. Try I,
Yeah.
I don't know some of the very specific names, like, I don't know what is it, like the terminology. It's a little confusing to me.
Okay. So after like practicing with some standard books, you are going to be very familiar. Okay.
Okay, yeah, if you could help me with that, like, then that would be
Oh,
really
yeah,
helpful,
yeah.
like the terminology and stuff. I think that's important. So then
Hmm.
after the three carbons, there's gonna be a carbonyl group, right? Off separately.
Huh?
Oh, sorry, I'm just looking at the example that you have here, like what you have here. Like after the propene, you have a carbonyl, right?
This is not propene, that is propane and carbonyl group. So that is a total four carbons. So that means it's bute and
Oh,
yeah,
oh,
butane.
propane. Okay. Sorry.
Okay. So
Propane. So
now we are discussing the B question.
wait,
Okay.
sorry, one more question. Wait, is this propane or butane? Because there's four total carbons. Are you considering that or just like the ones before the
This one, this
carbonyl?
one, this one, this one we are going with this one. The B one.
No, I know. I was just curious, like about the first one.
About the
Mm.
first one,
Yeah. Because you were mentioning like this is a butane, right? Butane. Oh, plus
butane,
carbonyl is butanol. Okay.
butanal, Al in the last. Why? Because of aldehyde. This is aldehyde group, na?
Oh, right. Yeah. It's not an alcohol.
Hmm.
I don't know. I was thinking the last part is though butanol. Okay.
Yeah. Okay. So now you tell me what I need to do after propene.
To get what you need to do. Is there gonna be like a split, or there's gonna be a reagent, right? That's gonna be
Read,
Mg.
read out the B question.
Oh, hydration of propene in the presence of dilute. Is it sulfuric acid or sulfonic acid?
Uric.
Oh my God. Okay. I think I searched up sulfonic, but it's okay. Like the video showed me sulfuric acid, so I mean, I think I should be fine. The
Mm.
sulfuric acid, I think uh, it's regenerated. I'm forgetting how. I think the sulfuric acid attaches itself to the double bond, right?
Sulfuric acid attached to the double bond.
Mm, the sulfuric acid is HSO4, right?
H2SO4.
Oh, H2SO4. Okay. Mm,
Hydration means
hydration means addition of hydrogen.
do you remember the first reaction from alkene to alcohol?
Yeah, it adds on. Hold on.
We
The
discussed.
nucleophile adds on. Oh, no, that's something else, right? Reaction mechanism. Let's see. Carbocation. Protonation of alkene. Protonation just means the hydrogen is added, right?
Yeah.
Yeah, that's what I meant to say. Like the hydrogen is added. Oh, from H2O first. Mm. So where's the sulfuric acid then?
Yeah.
Oh, okay. You just didn't write out the whole. Okay, you wrote H plus. Mm. It doesn't have hydrolysis, right? Or does it?
No.
No, it doesn't have hydrolysis. Okay.
This reaction we discussed like 4 to 5 times.
Which one?
This one.
What? But I don't have it in my notes. How is that possible? I thought you told me to research it. That's why you wrote homework next to it, so I could research it, remember?
See, yeah, only.
Oh, hydration. Yeah.
See each step in detail we discussed for this reaction.
Yeah, hydration.
Okay. Now tell me.
Oh, sorry, that's my bad. I thought the sulfuric acid reaction would be a little different. It's a hydration, so it should be the same.
Yeah.
Okay.
So see, read out the question, see, and now try the C.
Reaction of reaction of propanone with methyl magnesium bromide followed by hydrolysis. Okay, there in this one you have hydrolysis. The methyl magnesium bromide, I think one part like the methyl will react with the hmm methyl
You can write, you
propanone.
can, okay, so you can write the reaction over here. What do you think? Why read out this question?
Propanone. Methyl, pro- Hmm. I just watched the videos. I didn't copy down the whole mechanism. Should have
Why
done
you
that.
watch this? Like, why
Huh?
you need to watch videos after after discussing this part? Because I gave you the questions which we already discussed only. Okay. So if you are watching videos again for these questions, I don't think so that you are utilizing your time correctly. Because these questions are so much basic. You needs to work on approach. You needs to use your mind to solve out these questions. If you are not getting questions approached, then you'll ask me in the next class. Okay, if you are watching the videos, then organic chemistry is very hard for you. Okay, you needs to try approach, you needs to try new things, like why this particular group attack to here, why this particular group behave like this. That's the thing which you needs to understand. By watching videos you are not able to understood the concepts. And reactions are like there is thousands of reactions in organic chemistry, so how you will learn all these reactions, tell me, if you are watching videos? Hmm?
No, no, no. I think I misunderstood because I thought you gave me the homework to research. That's why I did that. Otherwise, I wouldn't have done that.
Okay.
Because
These,
remember earlier you gave me assignments like, oh, you should research the carbocation, you should
yeah,
research this.
that
That's
part
why
we
I
did.
did it.
Okay.
So
Okay.
I misunderstood you, maybe. I don't know. Like, I could have been totally wrong about what you wanted me to do.
Yeah, no issue. Now you do the C question, C part here. By your like how we can approach this question, like applying all the reaction
Hmm.
part which we discussed earlier. Do you have your notes?
Yeah. I was gonna look at my notes. What is the question? Reaction of propanone with methyl magnesium bromide. Okay. Followed by hydrolysis. So then this one
Now,
would be
by watching this like the statement, you needs to know methyl magnesium bromide. Methyl magnesium bromide. How can I write methyl magnesium bromide? What is the formula for that? Tell me firstly. What is methyl magnesium bromide? Methyl
mm,
means Me.
CH
Yeah, CS3
oh
also you can write. Yeah,
CH3.
yeah, CS3. Magnesium means,
Use Mg
and bromide means, yeah. So this
Br.
is a Grignard reagent. Now we know that this
Mm-hmm.
is a Grignard reagent. Now, like
Okay.
how we can deal with Grignard reagent? What one more reactant we need? So see, there is one more reactant is written. That is reaction of propanone. So now we
Mhm.
need to identify what is propanone. How I can write propanone? Tell me. What is the formula for propanone?
Propanone. It's a three
Three carbon.
carbon
Yeah.
chain. Yeah. Three
CS3,
carbon chain.
C double bond O, and CS3. Is this propanone?
Own.
Yes or no? Think about this. You can take your time. You need to analyze the thing first. Okay, and that's like after that you are able to solve organic reactions. Do I need to change any position of anything, like do I need to change position of carbonyl or anything else?
Propan. Propanone. So I've heard like I've seen in my notes I've seen like propanol. I've seen what's
Propanol.
propanol, right? Like OL. Okay, when we were talking about alcohol groups, but propanone.
How you proceed with that reaction if there is a propanol?
Oh.
Huh?
No. I'm just saying I'm more familiar with that name. Like I don't know what I'm saying. I'm sorry. I don't know. I was like talking about the alcohols. You know how there's like OL, the suffix.
Okay, so
That's what
propanol
I meant.
is written correct here. This is a carbonyl group. Now you tell me.
Carbonate. Okay.
Yeah. So this is the propanol we are using, double bond over here. Plus I'm using CH3 MgBr. So what will be the product in this case?
Um. So let's see. I think the BR because Mg is positive, right? I think the BR would try to attach to the carbonyl or carbon.
CH3 is R here. Mg means Mg. Br means X here. So how that bond will break? Here. R converting into R
Mhm.
negative, and this whole part is converting into positive. So this is Mgx positive. So R
Okay.
negative will attack over here. That means CS3 will
Mm-hmm.
attack O negative, Mgx positive, and here is CS3 will attach. Okay. Then in the next part, there is written as hydrolysis. Hydrolysis means H2O will come and break this bond and converting this into OH. So CH3 and OH. See, this is the product in this case.
Yeah, I just saw we went over that. Yeah, something very similar. We went over that. The Grignard. Just um. Wait, sorry. Can I like ask you so like I think I need to just like make sure I have like all of the notes correctly or something. Like I'm not missing.
So do you want to recheck or recross them? Cross check them.
Or like even if I have questions, because I really do want to be clear on this topic. I feel like this topic's been giving me a harder time. The first unit, like I answered all the questions that you told me like correctly. It was a lot easier. I don't this one's just like I don't know, it's just giving me a rough
Yeah,
time.
maybe you are taking wrong notes. You are not preparing notes correctly.
What do you mean by that? Like after class or like in class?
After class, or maybe in the class, you write down some things. Like if you missed out some reactions or some things, then maybe that is cause complication in things.
I think I do have the notes. I think I'm just like not organizing them in a proper systematic way. That's the main. I'll just send you. I think I really should send you my notes after session. Maybe you can just look at them.
Yeah, that's great. Then
Because
you
I also remember how you gave me assignments like you should go research carbocation, you should go research this. So I have separate notes for that, you know. But I don't
okay.
want it's just like all everywhere, like all over the place. So I think this is like causing me a lot of stress.
Hmm. Yes. So you need to prepare your notes only on on a single notebook or notepad wherever you are.
Okay, okay, yeah. Next time I'll do that. Or like moving forward from today, I'll just
Yeah.
have that in one section.
Great, great.
Um, but for like the hydroboration oxidation, I do think that I would need more exposure to that, but like maybe you can give me more problems on that specifically or
Hydroboration
something.
oxidation, that is easier part.
Okay.
I'm giving you some questions now. Okay, now you need to solve out each question. Okay, let's start. You can take your notes. I'm giving you some reactions. And all the
Okay.
parts which we discussed up to now, these are reactions are from only that part.
Okay.
Okay, solve out the D part.
Okay. Okay, D reaction of CH3 MgBr plus CH oh sorry, HCHO. Um okay. Um isn't that similar to what we just talked about right now?
Hmm? Yeah.
Wait, this one's not hydroboration oxidation, obviously. This is Grignard sorry. Grignard? Yeah, Grignard. Okay. Mm, CH3 MgBr. Oh, eight. See. I'm using my notes. That's fine, right?
Yeah.
Okay.
Done with D part.
No, 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 almost, almost.
Okay.
Wait. Mm. Mm. I think I have, yeah.
Okay. First one. What will be the product in this case?
It's gonna be, you're gonna have carbon bond into oxygen, hydrogen, or hydrogen, R group, and then
R group. From where you take R group here?
I thought you said I thought you said Br is like a no, it was, I thought you said CH3 was R. Or
Yeah.
no. Okay.
Yes, CS3 is R group. What is the IUPAC name of product? You can directly tell me what is the IUPAC name of product.
Hold on. The IUPC name. Let's see.
Yeah.
Butanol?
Are you sure?
Wait.
Okay, so you write down the reaction over here, how you proceed.
Mm,
Don't you need to take any sort of stress, anything? Okay, you can directly write down the reaction, like how you approach the question. If there is anything incorrect, then I'll told you that this is wrong.
yeah.
Yeah,
That's fine.
don't need to take stress so much. Okay. Yeah, I can imagine like you are so much into stress now. Don't need to.
Okay.
Okay, let's see. Let's solve this question. There is HCHO. Now the major thing is that you need to know how we can represent HCHO. Do you know
Yeah.
what is HCHO?
This one is gonna be a ketone, right?
A ketone like this. Hmm? Is this correct?
That's what yeah.
Yeah. This is not ketone. This is aldehyde.
Oh my God. Wait, so then ketone's in the middle, right? Of like a
Ketone is
chain.
in middle, but there should be carbon on both direction. Here is hydrogen, na?
Oh, okay.
So this is a aldehyde. And what is the name of this aldehyde? There is only one carbon, so this is methanol. This is methanol. Okay. Then we need to add CH3 MgBr over here. What is CH3 MgBr? CH3 MgBr is Grignard reagent. This is
Yeah.
methyl magnesium bromide. Methyl magnesium bromide. Okay.
Wait, sorry, ma'am. Can I so you mentioned that for an aldehyde it has an H attached to it, whereas ketone only has CH3 attached everywhere, right?
In case of ketone, we having carbon on both direction.
Oh, carbon. Okay.
Yeah.
Has carbon, not only carbon, just carbon, because there could be something else, right, with the carbon. Or is it just oh, it's just carbon by itself, right? There's nothing there.
Yeah.
So it's only carbon then.
Like CH3, CH3.
Okay, so that's like only carbon.
Yeah.
Okay. Yeah. I just wanted to make sure for a ketone. And then aldehyde has an H, and then aldehyde has H already in it, so that's how I guess I could remember aldehyde like H.
Yeah. In
Okay.
aldehyde, there can be only one side hydrogen, or it can be on two side, both direction.
Only hydrogen?
Yeah.
Okay, aldehyde only has hydrogen on both directions. Okay. Um, yeah, I mean, I can kind of tell you, like, if you still want me to, like, I can kind of show, like, what I did. So, um,
Mm.
the CH3 is R, right? So this is R,
Yeah.
and you mentioned this group by itself has a negative charge. Whereas MgBr, like this whole thing, is positive, or like it's positively charged. So it would be Mgx
Yeah. Mm.
plus like this whole thing, right?
Yeah.
Like that. So then there's like a tension between these two charges. This compound is very like, yeah, it has a lot of charge. So then the R minus will attach to the carbon.
Yeah.
And there's like a partial charge distribution between the oxygen and the carbon, right? The carbon is gonna have more partial positive, the oxygen is
No,
gonna have more partial negative,
no, no, no.
right?
Carbon having
No?
partial positive.
Yeah, partial positive and then oxygen partial negative, right?
Yes. Yes.
Yeah. So then after that, like this oxygen leaves, and then what happens is it creates an adduct, from what I can see on my
Yeah.
notes,
Yes.
adduct,
Yes. Yes.
intermediate kind of compound. So like you have like oxygen with
Like this.
carbon. Yeah.
Yeah.
Oh, wait, the way that I was gonna write it, like bond line. Not, this is not
Okay.
bond line. I don't know what this is called. Like a skeleton or something.
This one.
Like, sorry, what I was doing, like I didn't draw a bond line, right? Bond line is like that, like
This is
this or something.
complete structure.
What I drew?
Yeah.
Okay, I can. So do you want me to do that or bond line? I don't know if that's
Bond
like
line.
a.
Anything you can make.
Oh, okay, okay. So you have oxygen, and then you have carbon, and then you have
Mm-hmm.
hydrogen,
Mm-hmm.
hydrogen, and then an R group, right? So
Yeah.
this is the adduct,
Yes.
and then I'm just gonna label the
There is
adduct.
MgBr also on the adduct.
Oh, oh yeah, sorry. That's I forgot about that. That's oh my God. That's a huge mistake. Okay. Um, MgX. So then we want to get rid of this bond, right? Through hydrolysis. Like hydrolysis will allow that to take place.
Hmm.
So then hydrolysis will just like if you have like you continue and then you add hydrogen, right? You're adding hydrogen.
Mm-hmm.
And then how oxygen has the two lone pairs.
Yeah.
And then I guess, do you have to show like the whole like do you have to draw the whole water molecule it's by itself
No,
or no?
no, no, no. You can directly go with like you directly attach hydrogen to this oxygen.
No.
Directly hydrogen to this oxygen. That means hydrolysis will take place.
Yeah, like that. Okay. I think I'm like really overthinking how I drew the bond. I'm sorry. Like,
Yeah.
am I good with that? No,
For
right?
this H2O, not, but like for the
Oh,
R minus and all of them, they are correct.
wait, sorry. That's gonna attack this bond, right?
Yeah, see this O minus MgX positive is sort of ionic bond. Okay, so we doesn't
Okay.
need to represent in this notation over here.
Oh, we don't need to, so then what do we do? Just like leave
It
it.
doesn't need to do anything. After hydrolysis, we directly generate OH over here.
Okay, so we don't need to show any arrows. That's not necessary. Okay.
That's it. In intermediate and in adult form, we doesn't need to represent any arrow.
Oh, okay. So it's like useless to do that. Okay, we don't need arrow. I'm gonna write that down. Because I think I had an example like Grignard with like the arrow in there. Maybe I do that myself or something. I don't think you drew, or I don't know, maybe it's like not relevant. So
Yeah.
Yeah. And then the product is just gonna be butanol, right?
How butanol?
CH3 MgBr plus HCHO.
Firstly, you erase all this part which you draw.
Okay.
Okay. So you add double bond O minus MgBr, okay, and
Yeah.
CH3, and both in this direction there is hydrogen. Okay. After hydrolysis, you are getting this one CH3,
3.
and here is OH, and here is
OH. Yeah, yeah.
hydrogen. So can I represent this like CH3, CH2, and OH?
Yeah.
This is ethanol.
Oh, in my notes I had butan. Oh my God. Maybe I have like wrong notes then. This is what I have is totally wrong then because I wrote butanol. It should be ethanol.
Okay, now you start with a second, like a E part. Okay.
Wait, can you tell just by looking at this structure it's ethanol, or do you need to draw this out, this whole thing?
No, no, this is also okay. This is all. See how ethanol we are identify that this is ethanol. How many carbons in this? One, two.
Mm-hmm.
Two means
Yeah.
H.
Mm-hmm.
One OH group, so ethanol.
Okay.
Yeah.
Okay, yeah. Sorry, my bad. I don't know why like copied down butanol. It should have been ethanol. I'm gonna actually have to double check with you again. I think my notes there might be mistakes actually. It's okay.
Yeah.
One thing at a time. I'll just focus on this problem, then I can figure that out. Okay. But one ene
Yeah.
on hydroboration oxidation. Okay. Oxidation. Okay, hydroboration oxidation. Um, that's gonna be anti-Markovnikov. Okay. Do you want the whole mechanism?
No, no, direct product you can tell me. So what is butyl-1-ene? First you write down the butyl-1-ene part. Hmm. How we can write butyl-1-ene? What is the
Oh,
formula for that?
yeah, sorry, ma'am. I was about to I think that's but1-ene, right?
Great.
Yeah. Okay, so I at least got that right. That part is right.
Yeah.
But1-ene on hydrogenation oxidation. Okay, so you want the product, right, ma'am? So
Yeah.
the product will be it's gonna be anti-Markovnikov, and then anti-Markovnikov means on the it will attack on the less substituted side. So just direct product. Okay. So then it would be. Oh wait, no, I don't think it's gonna be a double bond. Sorry. But1-ene station. It's gonna be added to the list. Or wait. Oh, less substituted. Oh, okay, wait. Less substituted. Okay, wait, 1, 2. Less substitute anti-Markovnikov. So then here, I think it would be OH would be here, and then hydrogen would be here.
Yeah. That's great.
Okay, I mean, these reactions are not crazy. They're doable. I just need more practice, that's all.
Yeah. These are so easy.
They are.
Yeah. Now do the F.
But I do think I wrote down some incorrect notes, so maybe that kind of misguided me or something. I don't know. That
Yeah.
wasn't
To prepare correct notes.
right. Okay, which statement is correct? Okay, A. HBO gives Markovnikov alcohol. No, that's incorrect. It's anti-Markovnikov. B. OMDM quotation mark anti-Markovnikov alcohol. No, it's Markovnikov. C. HBO proceeds via electron C plus. No.
What?
Wait. Hydrogen oxidation is through double bond, right?
Yeah.
So there's no carbocation, right?
I don't know. Tell me.
I don't know if like you're implying that I'm wrong or you just want me to justify myself.
Yeah. To justify yourself.
Just justify myself. Okay. Um, so based on my notes, like what I have is like whatever answers I gave for A, based on my notes, I have that oxymercuration, demercuration is Markovnikov, hydroboration is anti-Markovnikov.
Mhm.
And then HBO, based on what I have in my notes, like we did a few examples, I think, 1 or 2
Mhm.
examples. And the there was a carbocation that formed for hydration, and then that's where you get alkyde shift, hydride shift, but none of the other like reactions have that. So it's based on a double bond.
Yeah. So
Right.
if only in case of hydration, in only case of
Mhm.
hydration, there is carbocation will form. So that's why hydroboration oxidation can't proceed via carbocation.
Mhm.
That's the reason. Okay. Okay. Then
And then D, OMDM proceeds without what is that? I'm sorry, I can't read.
rearrangement.
Oh, rearrangement.
Rearrangement of what?
Carbocation? Like your question? I think that's what you're trying to say, right? Rearrangement of carbocation.
Yeah.
Mm-hmm. OMDM? OMDM proceeds without that, yeah.
Yeah. So this is correct.
Yes.
Great.
The only one. That's correct.
Yes. Okay. So now, any doubt up to now? Can we proceed further?
Like what do you are you we're gonna start a new topic completely or chapter?
No, today, like now I'm giving you some homework, then you ask your doubts, okay? Then we end this session. So firstly, your homework is to identify functional groups. Functional groups. All sort of functional groups. Okay? Like how, like what is ester, what is alcohol, what is acid, what is
Mhm.
acid chloride, aldehyde. I'm giving you like 10 to 20 questions in next class, like in next class. So you need to identify that in a particular given compound, this is the functional group. Okay.
Okay.
Okay. So let's suppose I'm just writing here firstly. Okay. Double bond
Mm-hmm.
O. Here is hydrogen. Here is, it can be hydrogen. Oh, sorry, it can be R group. R means carbon group, or it can be any hydrogen. Okay, so this group is known as aldehyde. So I'm writing the functional group, and then you needs to like remember all these things. Okay, then if let's suppose there is, you can write down with me. This group is known
Mm-hmm.
as ketone, and if there is double bond O, R here. So in that case, this is ester. Double bond O and OH. And if there is R, or it can be hydrogen. So this is acid. If there is R, double bond O, X. So it's acid halide. And ether, there is, if there is a O in between any R, or yeah, majorly it will be R. So this is ether. And if there is any C triple bond N, so that is cyanide. And if there is NH2, then it is amide. Mm, then this will be phenol. Okay, you note down this thing. Give me 2 minutes. Okay, I'm coming in 2 minutes. Okay, done. Functional groups.
Yes.
Okay. Then, after functional group, there is some terms which you needs to identify. That is hydration, hydrogenation, hydrolysis, hydrolysis, and esterification, esterification, and hydrogenation, hydrolysis, hydration. Okay, halogenation, halogenation, and this is hydration, hydration. Okay, so these are some terms, okay, which you needs to search.
Okay.
Search about these, and the functional group you needs to remember. Okay, so I gave you
Memorize.
some,
Memorize?
yeah, memorize.
No.
After that, in tomorrow's class, I'll give you some organic compounds via IUPAC name, and throughout them, you need to identify that there is acid halide, acid halide, there is ketone or aldehyde or ester, anything. Okay. Any doubt up to
I
now,
see.
anything you want to ask me, you can ask me. Okay.
Yeah, yeah, of course. I'm just looking through everything comprehensively because I
Yeah.
just want to leave with a clear idea of like what I have in my notes and stuff. Wait, is it okay if we can go back to the first day that we started this unit or this chapter or whatever? I don't know what you call a unit or chapter. I don't know.
Okay, so I share this notebook, this OneDrive notebook to the sub.
Okay.
Okay, and but
Mm.
like maybe that is not open in your area. That is also possible. Okay, no issue. You can cross check here only if there is any possibility to not open or anything. Okay, so from here, yeah, from here alcohol will start. Okay, tell me wherever you wants to stop me. Okay. IUPAC
Mm.
name. Any doubt, anything here? The instruct.
Wait. Sorry, ma'am. Sorry. Give me 1 second. Hold on. Oh, why are my notes like this? Okay. Wait. Reaction mechanism chapter that I have. Wait. Sorry, give me 1 second. Let me cross check with my notes. Mm, or maybe, uh, okay, I'll try to take pictures because I think it's gonna
Yeah,
take some time for me to sort it out, you know? I don't think I can just do all of it here.
yes. You can take screenshot of all of them.
Okay. Okay. Wait, sorry, I think there's something missing at the top, is there?
This is just alkyl and methyl group.
Oh, okay. Okay, this part is done.
Question practice.
Yeah, it's done. More practice done. 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 Sorry, I'm just like repeating myself so many times. I think you're covering a little bit of yeah.
Okay.
Okay, done.
Yeah.
Done.
Take it from here. That
Done. That's all?
no, no.
Oh. Wait, sorry, ma'am. Did I get
This whole thing put together. Yeah.
Yeah.
Yeah, you can.
Okay. That part's good.
Okay.
Okay, good. Good.
And yeah, from here you can take.
Good. Good.
Do you want to take notes for oxidation and reduction also?
Yeah, sure, why not? I mean, a lot of my notes are like wrong, so I have to cross-check.
Mm-hmm.
Yeah.
Sure.
Okay. Is this all we covered? Oh. Oh, this is from a previous. Is this from today?
Yeah, this is
Oh,
from today, from here.
okay. Mm.
Mm-hmm.
Yeah, so now I just want to see if I have any questions. So
Yeah.
for hydroboration, so firstly, for all the three main reactions that we covered, um, does it have anything to do with SN1 or SN2?
In chemical, like up to now, we only discuss method of preparation of alcohol. After that, we are going to discuss that chemical reaction of alcohol. Okay. So in chemical reaction of alcohol, we proceed with SN1, SN2 elimination, like even each. Okay. Esterification. That part we cover in next class if you memorized all the functional group well. Okay.
Okay, so
Uh-huh.
okay, because I was mistaken that this was a reaction mechanism, so it's not a reaction mechanism chapter, right? Like, so then what would it be called, like this chapter?
This is alcohol.
Just alcohol, okay.
Just alcohol. So reaction mechanism is not a chapter. Let's suppose I'm studying the chapter alcohol. So in alcohol, how many reactions are there? So each reaction
Mm-hmm.
having different mechanism. So that is reaction mechanism. Then we discuss ester, alkene, alkane, any part. So in each part there is different mechanism. So that whole mechanism is reaction mechanism part. That is known as
Okay. Oh, okay. So it's not really like a chapter or anything, right?
yeah. No, no.
Okay, okay, okay. Um, degree of carbon penetrating. I'm good with allylic, vinylic. I'm good with that stuff. I think IUPAC, I'm also good with that. Um, and then we talked about nucleophile, electrophile, right? So we've been working with that. So nucleophile, electrophile, oxidation reduction. Um, I think I'm okay with that. And then let me just double check. I think IUPAC, I might need to go over like aldehyde ketone naming a little bit. The
Yeah.
other aspects are okay. And then method of so when we started talking about hydration, oxymercuration, demercuration, and hydroboration, was that part of that this was all part of method of preparation?
Yeah. The up to now all the part of method of preparation of alcohol we discuss it. All the reactions.
Method of preparation. Okay. So hydration. Okay, I still need to memorize the reagents, I think, of
Mm,
the
yeah.
I have to memorize the reagents, right?
Yeah.
Mm, oxymercuration. And for now, should I just leave the mechanism for oxymercuration and then hydroboration? Should I leave them?
Yeah. That part you need to leave because that
Okay,
is.
but the
But
mhm.
if there is that part comes in your syllabus or anything, then we go with that in the end.
Okay, so I don't need to stress, right? Because I was really
No,
stressed
no,
up.
no,
I
no,
was like,
no, no.
do I need to know? Okay. But I need to know the products.
Yeah, you need to remember products with which law or which type of reaction, which type of product we are getting, like anti-Markovnikov or Markovnikov, like that.
Okay. But for hydration, I would need to know how the carbocation is formed and rearranged and all that stuff. That's
Yes.
important, right?
Yeah, yeah, that
Okay.
is it. Because the rearrangement of carbocation will come again and again, like in SN1, then we with E2 and even and all.
And then the Grignard and reducing, I need to know the full mechanism, right?
Yeah, Grignard is only two-step mechanism. That is very easy.
Mm-hmm.
That is not
Yeah,
even a mechanism, that is a reaction, general reaction.
just a
And
reaction.
yeah, and in reducing agent, there is also reaction. There is no mechanism.
So then what is a mechanism and what's a reaction? Like what?
Mechanism, like a reaction means a general reaction which is completed in one step. Okay, one
Okay.
step or two, maximum it will be in two steps. But mechanism is related to there is a lot of reactions, a lot of steps in that particular reactions, and after there is a possibility of rearrangement, and if there is a reaction mechanism, so there will intermediate also present. Intermediate means there is a possibility of carbocation, carbon ion, carbon free radical. Okay.
So then hydration reaction falls under that.
Yeah. So do you remember that we studied a complete mechanism for hydration, like the protonation and then attack of nucleophile, then deprotonation. There is three steps.
I think so.
Yeah. So that is a reaction mechanism. Reaction mechanism for hydration. Sorry.
Yeah, we did study a mechanism. There was one
Yeah.
example.
We also
Yeah.
studied mechanism for hydroboration oxidation and oxymercuration demercuration also. But that mechanism you didn't need to study for now, at least.
Oh,
Okay.
okay. And then I need to memorize the reagents, right? The what's it called? Reducing reagents
Um, yeah, reducing reagents like
and
NaBH4,
Grignard.
NaBH4, Grignard. Yeah, that is easy. Like after solving, like after we like let's suppose we are discussing alcohol from now.
Mhm.
Okay. After discussing after alcohol we start alkane. So in that part also Grignard will come and all the reagents will come. So you doesn't need to remember or it doesn't need to memorize them. They automatically memorized when we do some reaction part. Okay. You
Okay.
need to memorize functional group for first, like how to identify
Mhm.
functional groups. And yeah, that's the only thing you need to memorize. And all the terms are going to use again and again when we discussing some part. So in that case, you will memorize all by some practice only. Okay.
Yeah, I know. Definitely, of course, I definitely need more practice. Like, there's obviously no like
Yeah.
nothing compares with that. I
Hmm.
also don't, sorry, I had another question. What does adduct even mean?
Adduct means that is not a reactant, that is not a intermediate, that is not a product. So anything that is not lie in intermediate product and reagent or reactant part. So that is adduct. Okay. There is no any hybridization of adduct. There is not a perfect shape or anything. They are like all type of reactant and reagent are attached to that particular carbon.
I see. Okay.
Hmm.
Okay. I think that should be it. Wait, I also, sorry, I had one more question. When you mentioned that we didn't cover any mechanisms yet, isn't you mentioned that if something is just a reaction that occurs in one step, right? Doesn't SN1 just occur in one step?
SN2 will occur in one
Or
step.
oh, SN2.
Yeah. But in SN2, there is a transition step will form.
Okay, but there's no the carbocation is formed in SN1, right?
Yeah, so reaction
Oh.
mechanism is like how we deal with reactants and reagents. There is not a particular, you know, there is not a particular way to identify that how they will go. So reaction mechanism is basically our approach to any reactants and reagents, how they will do, how they'll attach to each other. Like in carbonyl, carbon is partially positive, oxygen is partially negative. So how they attack and all of that stuff.
Okay.
Yeah.
So SN1, there's a carbocation, and then for SN2, it all occurs in one step, right? But I guess that's not really as important right now. But I was just curious
Yeah.
when you said that it all happens in one step. So I was thinking like, is
Hmm.
SN1 or SN2 like the same where it happens in one step? Like hydration, there's a carbocation, right? So I was thinking, is like SN1 similar
Hmm.
to that or no? That's what I
Yeah.
was thinking.
Yes,
Okay.
it's
Okay. Yeah, that's all, ma'am.
okay.
Thank you so much for your help and your guidance and everything. Thank you.
Okay. Bye.
Bye-bye.